Today I am gonna teach you the concise chemistry of class 9, and that is chapter 2, chemical changes and reaction. So what you will learn, first you will learn what is a chemical reaction, then we will see that what are the chemical changes generally occur after the chemical reaction. So what is chemical reaction? Chemical reaction is basically a process of breaking chemical bonds. See here that a chemical reaction is the process of breaking the chemical bonds. Now, what is chemical bonds? Chemical bonds is the simple electrostatic force between two atoms of a molecule. The force of attraction between two atoms in a molecule or in a compound. So here is the definition of chemical bond. A chemical bond is the force that holds the atoms of a molecule together as in a compound. So what is chemical reaction? A chemical reaction is the process of breaking the chemical bonds of the reacting substances, that is reactants. What is reacting substances? In a chemical reactions, the substances those who are present in the left hand sides are known as reacting substances, and the substances those who are present in the right hand side are known as products. So here you can see that copper carbonate here is the reactants and the product is copper oxide and carbon dioxide. So reacting substances, that is reactions and reactants, and making new bonds to form new substances, that is products. So what we have to do, we have to simply breaking the chemical bonds of the reacting substances, and we have to make another bonds that will be known as products. A chemical change or chemical reaction occurs when particles collide, and this collision may be direct combination, or we have to apply some external energies, that is light energy, electrical energy, heat energy. So a chemical change or chemical reaction occurs when particles collide. Collisions occur when reactants are in close contact, that means synthesis or direct combination, or by supply of energy. Thus, one or more of the following conditions are necessary for a chemical change. So, let's see what are the conditions. Actually, these are not the condition, these are the process by which we can breaking the chemical bonds between solids, between solution, that means between liquids, between gases. Okay, so let's see the types of chemical change and their necessary condition. So mixing, in some cases a chemical reaction occurs when two substances are mixed in their solid states. Two substances when reacts in their solid states, that is known as mixing. Mixing not only done by solid state, it is also can be done by solid or gases, by liquid or liquid, by solid or liquid. Okay, so this is close contact between solid states. Here are the examples. Iodine and phosphorus. When iodine and phosphorus react explosively when brought into close contact, we generally use iodine and phosphorus in bomb making. We generally use iodine and phosphorus, as when they react, a explosion is generally occur. And the second example is lead nitrate. See, the color of the lead nitrate is white color when it reacts with potassium iodide. Both are solid state. Okay, so when lead nitrate reacts with potassium iodide, it forms potassium nitrate and lead iodide. We can see here that we are simply breaking the bonds between lead and nitrate, and we are making new bond, that is potassium and iodide. And also potassium and iodide, we are breaking the bond between potassium and iodine, then we are making potassium nitrate. So the color of the lead nitrate is white color and the lead iodide is yellow color. We have to memorize these things. Potassium iodide is also white. Both the solids are white color, but the products are yellow color. Lead nitrate is white color. Potassium iodide is also white color, but lead iodide becomes yellow color. So this is mixing process. Now solution, that means the reacting substances will be in liquid state or molten state. So here we can see that in some cases a chemical reaction occurs when substances are mixed in, that is molten or aqueous state. So there is a difference between molten or aqueous state. Molten means you have to melt that substances by heating. So this is known as molten, or aqueous state means the substances in solid, that means the solvent, they are the solvent, that means the substance is in water. Okay, if you dissolve the substance in water, then it is known as aqueous state. So, so the first example is oxalic acid crystals and sodium carbonate react in water solution only. And what are the second example? The second example we can see here that sodium chloride and silver nitrate both are in aqueous solution. When reacts, it forms silver chloride, and this is white precipitate, and sodium nitrate. Sodium chloride and silver nitrate also react in solution state to form the precipitate of silver chloride and sodium nitrate. So these are the two examples of solution. Let's see the third example. Third point is heat. That means we are, so how we are breaking? By generally we are breaking the bonds between simply mixing. This mixing process can be solid solid, it can be liquid liquid, it can be solid liquid. Now we are breaking, trying to breaking the bonds by using some energies, that is heat energy. So that means what we have to do, we are simply decomposing the element. Some chemical reactions occur only on heating. Example, copper carbonate. When copper carbonate decomposes on heating into copper oxide, if you give some heat to the copper carbonate, then what will happen? Here the del symbol means you are heating the substances. Okay, so del means we are applying some heat to the reaction. So what we can see that copper carbonate simply decomposing to copper oxide and carbon dioxide. So what we are getting by heating copper carbonate, we are getting a solid, that is copper oxide, and a gas, that is carbon dioxide. Next, lead nitrate. When we are heating lead nitrate, then what we are getting? Lead oxide. The color of lead oxide. Okay. The color of nitrogen dioxide is brown color. Brown color, and this color of lead monoxide or lead oxide is yellow color. The color of lead monoxide is yellow color. Here we can see that lead nitrate decomposes on heating, leaving yellow residue, lead monoxide. Lead monoxide, and nitrogen dioxide, the color of nitrogen dioxide is brown. That we have to keep in our mind. What are the color? See here that the color of potassium nitrate, sorry, lead nitrate was white. The color of lead iodide was yellow, and here the color of lead oxide is also yellow. The color of lead iodide is yellow, the color of lead oxide is yellow, and the color of nitrogen dioxide is brown color gas. Next, light. That means the reaction will be happen by the external energy, that will be light. So what we can see that some chemical reactions take place like photosynthesis by the action of light. These are called photochemical reactions or photolysis. Molecules of the reactants absorb light energy, get activated, and then react rapidly. So this is the equation for photosynthesis. Plants form glucose from carbon dioxide and water in the presence of light. Carbon dioxide plus 6H2O, glucose and oxygens are generally produced. Okay, and the next reaction is hydrogen and chlorine. When reacts, it produces HCl during the presence of sunlight. And what we can see, that chlorine water, that is chlorine plus water. See here, chlorine plus water. When exposed to sunlight, oxygen gas is evolved. Okay, oxygen gas is evolved. See here, here is some note that you have to keep in your mind. Solution of silver nitrate solution and hydrogen peroxide, AgNO3, this one, and hydrogen peroxide, H2O2, are kept in brown bottles. It's very important that silver nitrate, why silver nitrate and hydrogen peroxide kept in brown bottles? This is a very important question, as because of they simply decomposes during the in the presence of light. That's why we are keeping these two things in a laboratory in a brown bottle, that is silver nitrate and hydrogen peroxide. So silver nitrate, when decomposes, it forms silver, nitrogen dioxide and oxygen. What is the color of nitrogen dioxide? Brown color. What is the color of silver iodide? Yellow color. Sorry, lead iodide, yellow color. Lead iodide is yellow color, and lead oxide also yellow color, and lead nitrate is white color. Potassium iodide, white color. Okay, so these are the important elements that we have to know, the color of the elements or molecules, that is compound. Now we are giving some electricity as external energy source. So whenever we are talking about electricity, the first thing that we always think about, that is electrolysis, that is breaking of water into hydrogen and oxygen, and the water has to be in acidulated water. So electrolysis of, okay, let me read this. Certain chemical reactions like the decomposition of certain compounds occur only when electricity is passed through the substance. Example. So first example is electrolysis of acidulated water. Occurs only in the presence of electricity to give hydrogen and oxygen. Hydrogen, when we are passing electricity through acidulated water, hydrogen gas and oxygen gas will evolve. On passing current through molten sodium chloride, NaCl, molten sodium chloride, sodium and chlorine are separately obtained. Sodium and chlorine are separately obtained. Now pressure. So what we have seen? We have seen first the mixing process, that is between solid and solid, then liquid and liquid. Then we can see that we are giving some external energy for decomposing the compounds. That means light, heat and electricity. Now pressure. Some chemical reactions take place only when the involved substances are subjected to high pressure. High pressure, that is mercury chloride and potassium iodide, when rubbed in a mortar, give a scarlet colored substance called mercury iodide. In this case, we need high pressure. And also during the preparation of ammonia, we need minimum 200 to 250 atmospheric pressure. When nitrogen and hydrogen reacts, when subjected to high pressure, produce ammonia in the presence of iron as catalyst. Yes, here we need a catalyst to increase the rate of the chemical reaction. What is catalyst? This is another thing. Catalyst is generally uh, catalysts are those things that those itself they are not reacting. what they can do, they can simply increase the rate of reaction or decrease the rate of reaction. So some chemical reactions need a catalyst to accelerate or deaccelerate the rate at which the reaction occurs. The catalysts themselves do not take part in the reactions. The catalysts themselves do not take part in the reactions. Example: when when potassium chlorate decomposes, we generally need 700 degrees Celsius. But by the using of manganese dioxide, the temperature can be reduced to 300 degrees Celsius. So potassium chlorate decomposes only at 700 degrees Celsius, and even then the rate of release of oxygen is very slow. Okay, but when potassium chlorate is heated in the presence of manganese oxide, decomposition begins at much lower temperature, that is 300 degrees Celsius, and manganese dioxide remains unaffected. Thus, in this reaction, manganese dioxide acts as a catalyst. 2KClO3, potassium chloride, and oxygen. Potassium chlorate becomes potassium chloride and oxygen. When ammonia reacts with oxygen, ammonia, that is NH3, 4NH3 plus 5O2. This is a very important reaction. Ammonia reacts with oxygen to produce nitric oxide, 4NO, and water vapor in the presence of platinum catalyst. These catalysts can be two types: positive catalyst and negative catalyst. Positive catalysts are generally those who increase the rate of reaction, that is accelerate the rate of reaction, and negative catalysts are those who deaccelerate the rate of reaction. When a catalyst accelerates a reaction, it is known as positive catalyst. For example, the rate of decomposition of hydrogen peroxide gets increased in the presence of manganese dioxide. The rate of decomposition of hydrogen peroxide by the presence of manganese dioxide, that is water and oxygen. Sorry. And negative catalyst, we are coming to this after discussing negative catalyst. Negative catalyst, simply a catalyst employed to retard a reaction, is known as negative catalyst. And what is the example? Phosphoric acid, alcohol, these are the negative catalysts. Phosphoric acid, H3PO4, alcohol, these are the negative catalysts. Retard the rate of decomposition of hydrogen peroxide. The rate of oxidation of chloroform decreases in the presence of alcohol. See here, what is promoter? Promoter is another substance that influence the rate of chemical reaction by simply improving the efficiency of the catalyst, are called promoters. For example, molybdenum is a promoter. When we are producing ammonia, during the manufacture of ammonia, iron acts as a catalyst and molybdenum as a promoter. Molybdenum increases the efficiency of the catalyst iron. And what is negative catalyst? That we have already discussed. Okay. Here are some note that certain chemical reaction proceed by absorption of sound energy. So what we have seen? We seen light energy, we have seen electrical energy, heat energy, and here we can see that acetylene breaks up into carbon and hydrogen by absorbing sound energy. Very important reaction. Acetylene C2H2 breaking into carbon and hydrogen by absorbing sound energy.